Good afternoon, and welcome to our webinar here at Audio-Technica. This webinar today, we're going to be covering presentation audio, and really we're trying to help let you know all the things that you need to consider to make it a little bit easier to deal with presentation audio. And there really are a lot of aspects that you have to look at. So again, I'm Mark Donovan. I'm the Director of Commercial Applications here at Audio-Technica US. And then we have over here to my left, we've got Dan Pelletier. Dan is the Applications Engineering Manager for Audio-Technica US.
Thanks, Mark.
You're welcome, Dan. So together today, we're going to be going through these things, and you can see some of the stuff that we have on the table, all the different options that we have. And really, at the end of this, what we kind of want to make sure that you have is an understanding of some of the key technologies that we're using. Everything from beam forming microphones, to wireless gooseneck microphones, that kind of thing, and understand, not just what these technologies are, but the pros and cons, because there's good reasons that you would need to choose or want to choose one over another. So we want to make sure that you understand what those are and understand really that you're asking yourself the right questions when you're looking at your presentation audio. And when we're talking about presentation audio, that can be anything from what I'm doing right now, which is a webinar kind of thing, or distance learning. It can be a presentation to a board of directors in a corporate application, all these different kind of things, but it's capturing that voice of a presenter to get it out to someone, whether they're in the same room or whether we're talking distance at the other end of a call like what we have today. And we really want to talk about these different methods, and you'll get a chance to hear some of them too. We're actually going to step through some of the different things so that you can actually hear the difference between a handheld microphone, a body pack microphone, a gooseneck microphone. So these are really some of the things that we're going to be going through today. And of course that covers everything, as far as how that would work, is things like corporate, education, commercial, all these different verticals. So really, again, some of the objectives that we're going to have here is we want to make sure that you understand some of the key mic technologies that we're talking about for presentation audio. You want to understand the comparison between these different mics and be able to hear that, and then really that guidance in helping to choose the correct one. So also, so this is being recorded, so this will be available at a later time so that you can review all this. I guess we'll have it on our YouTube channel. I'm getting the thumbs up from Rory Garrity over here. Rory is in our marketing department, and he's running the whole show. He's running all the buttons back there today, so I thank him for that.
Thank you.
You won't be able to hear him. We didn't put a mic on him, but he's here. So overall, what are we talking about in presentations? What are the things that we have to look at? So we've got to consider not just, hey, I've got a presenter, but you also got to figure out just how that presenter is going to use things. And I'll tell you why that's an important thing. Is because some presenters really understand the technology. Right, some of these professional presenters or professional educators really understand the technology. They know how to place a lapel mic or how to hold a handheld microphone or where they can walk to maintain themselves within these pickup areas. But at the same time, there's a lot of people out there who have no idea. And the reality is let's just say I'm in a corporate environment and you've just got some director of some department in the manufacturing or in the warehouse that's giving a presentation. They don't know anything about audio, and they shouldn't. They don't have to. But as the decision makers on the technology, the integrators, the buyers that are choosing the technology, you've got to understand who your end user is, who's going to be using it, and how they're going to be using it. And so that's going to really help hopefully guide you through a lot of that. And it really can be daunting at first, but actually once you start to look at some of these differences, it'll make a lot more sense. And also it's going to help you make things simple for the process itself, because ultimately that's what you're worried about, is how hard is it going to be for those people who are presenting, those people who are coming in to use the system to actually do that.
You got someone from the chat saying that they don't have audios. Is anybody else experiencing this as well? Can we be heard?
Well, that would be not a great way to start in an audio presentation. Do we have
Okay.
audio?
What we might be working with here is if you are able to join the conversation with your audio here. So I'm going to go back here to my Zoom page. In the bottom left, it says join with audio. So if you do that, then we should be good to go. All right, thanks everybody. Appreciate the feedback.
Good, because that would be a panic moment.
Yeah.
I'm sitting here talking about microphones, and then I don't have a microphone. But thanks, and please, I guess I really didn't say this, but if you've got some questions, especially as it relates to how the actual technical flow in the audio and video here, but if you have questions, shoot them in the chat. We'll answer them as things go, but we're also going to have a Q&A session at the end. So if you've got some questions when it's all over and done with, we can make sure they're addressed then. Out of all these different things that we've talked about, we've got all these different technologies. The real focuses that we're going to talk about today is we're going to talk about our ATND1061 beamforming array. So this is a beam, they've been around for years. This is your automatic beamforming microphone array. So that's going to be able to, we're going to cover that, some of the pros and cons and the advantages there. We're also going to talk about, this system here. This looks like a wireless access point, but this is actually our receiver for our engineered sound wireless. So we're going to talk about that using that wireless decision there. And also, we have our System 20 Pro wireless, which is the receiver up front here. This is the System 20 Pro, which we're going to talk about that and go through these three different ones, which cover, different technical topics, the different capabilities of each one of them, different price points of each one of them. But we're going to go through those three mainly. Now, going through some of that, the beamforming arrays obviously is the most, is the one that has a lot of the buzz most recently. And actually starting off on the audio here, that's what you're listening to. So Dan and I sitting here, we've got a microphone up here in the ceiling just above us, a beamforming microphone, one of the Audio-Technica ATND1061s. And the great thing about those is they're pretty cool. They're simple. You don't have to have anything cluttered in your desk. You don't have to worry about where somebody clips something on and all that kind of stuff. So that's great. What is the downside? Well, they do cost a little bit more. They are a little bit more expensive, so there is a cost involved. These are products that are picking up at a distance as opposed to picking up closer, which you're really going to see the difference there when we start switching through the microphones. And then I'm going to talk about two other things, fixed area and individual. So you've got that beam forming up in the ceiling. You have a fixed position type, which would be like a gooseneck microphone or boundary microphone that's fixed in a position in front of you. And then you're going to have an individual one, which is actually a spot miking, as in the music world, what you would think of, but actually putting a microphone, effectively attaching that microphone to an individual so as they move around, it's able to pick them up. And so those are the three different types that we're really looking at in this presentation. I'm going to talk a little bit more here, starting with this 1061, with this ceiling array. So the beamforming array here, what's really nice about this is the beamforming array is something that is automatic. It can actually sense where a voice is coming from. It detects the location of that voice. And as that voice moves around, that beam is able to follow. And actually, I'm going to do that right now, is I'm going to stand up and I'm going to walk around this table. So as I stand up and I move off to the side here, you're actually, showing the software, changing over to that. You can actually see that green dot. Let me get back in. Let me get back in my zone there. I actually walked outside of the zone. But you can see as I walk around here, this stays at a fairly constant level as I move around because that beam is centered and following me. Because this technology is able to determine where my voice is coming from, it's able to keep that in place. Now, one of the really cool things about this, one of the great advantages of this, is you're talking about a situation where you've got somebody that moves around a lot. Especially in instruction, you've got a classroom type of application. Instructors rarely like to stay in one place or stick to a podium. They like to move around, and they may be moving around to point at a presentation or a display. And so having this that can automatically follow them around has a great advantage. Now, of course, we all found out from COVID a few years ago that the advantage there also was you didn't have to have hands-on. So you didn't have people handling it. And that was obviously a big problem with COVID. But after COVID was passed, we started to realize there's actually a lot more benefits to that, is just not having to touch the technology. This way, literally, a presenter can just walk into a room and go. And so that's where you have a lot of great advantages with using one of these beamforming arrays, the ATND1061 DAN, which we have here. And a couple of the other advantages too, aside from just that part, is there's a lot more stacked into this. There's a lot more processing. And actually, I'm going to kind of go into that a little bit. I'll show you on the screen here of what we've got talking about. So shifting over to the screen, this is a top-down view. And actually what I've got here is I've got these different zones that I can have beams that are enabled. And you can see here this little green dot is dancing around and it's showing my voice. So my voice is present in this number 1 zone, and you can see it on the metering on the right. And then when Dan talks, he's going to be talking in a different zone, and you'll see how that shifts over to that one.
Right. So as I said previously, I am monitoring the chat. Well, I didn't say it on the webinar, but I did put it in the chat that I'm monitoring it, but this is what I sound like in this particular zone.
Now, if you notice there, as we went back and forth, there were these 2 different channels, those 2 different audio channels that we were both on. So even though this is just one device that's up in the ceiling, we actually have 2 beams that are showing our audio. Now, what you're seeing right now is you're seeing that channel 1. You can see it's the stronger level, and that's my voice there. And you can see it coming in a little bit into channel 2 because the way that our system works is it puts that other beam into a standby mode or an inactive state. It doesn't completely cut it off. You can if you want to, but it doesn't completely cut it off so that you still maintain the smoothness in a live field. But then when you have conversations that are going back, you know, like I can ask Dan, hey Dan, is there any other questions going on in the chat?
So far,
right
there's
now?
no other chats going, no other questions in the chat.
Now, there's 2 things I wanted to note about that, and this is the processing that's built into it. One of them is you saw it switch back and forth as one of us talked and the other didn't. But when we were talking at the same time, when there was a little bit of talk at the same time, it maintains a constant level output. And what that is this is a gain sharing auto mixer, which means that it's going to maintain a nice steady level that's going downstream. So the people on the other end of this Zoom call or at the other end of a Teams call or whatever are going to get that nice constant level. So like if Dan and I are talking back and forth, I know you got notes there, Dan. But I'm
Yeah,
sure
I
you're
have
not
some
reading
notes
all
here.
of
I'm not
them.
really following the notes, but but you are right on target with your timing there. It's pretty impressive.
Actually, I'm probably not that on time.
Oh,
but
it's close.
It's close. So, so you'll notice though, and you can see it on the right with the auto mix, that they stay at a fairly constant level there. So having this processor built into it, this automatic mixing that can handle multiple people talking in the same time, just like what you heard, that's another powerful thing about having this beamforming array. Also, just so you know, what's also built inside of this thing, we have some noise canceling, so it can get rid of some hiss and hum and things like that that you might have in a room from acoustic noise that exists in the room. It also has an echo canceller in it, which is critical for applications like what we have going on right now. And in fact, it is engaged in this system. It's you know, that's what's going to keep any echo going on when we have multiple channels open. But the nice thing about these ceiling arrays, again, you know, you've got a piece that's got a lot of processing built into it. So what are the downsides then? Why don't we always just use a beamforming ceiling array? Well, the one is the cost, okay? They do cost more. There's no way you can get around that. There's going to be more cost involved because of all that processing. And it really does take a lot of you know, number crunching and computing inside of one of these devices to make those beams do what they do, to make sure all that different processing in there. So that's going to be a little bit on the higher end of the cost, perhaps not as much as you think, but a little bit higher on the cost. The other thing too is that you have to be able to mount it somewhere easily. Now, I know that sounds obvious, but you know, you do have a height limitation. So the coverage of this microphone is actually a 5-meter radius. And you can actually think of it a big bowl that it can pick up underneath that microphone that is a 5-meter radius bowl. Now, the higher you get with that, the higher that whole thing goes, which means me sitting here at a seated talker, that that circle of how big it can cover is going to get smaller and smaller and smaller. So if you're in, for example, a teaching auditorium that has an open ceiling that's very, very high, maybe it is up to 7, 8 meters up, 25, 35 feet up. You can't mount one of these microphones that high. It's just not going to be able to pick up that distance. And which, by the way, that range limitation is pretty much the same whether you're talking about our products or some of our competitors' products. You just can't take them and lift them up, infinitely high into a space and expect them to pick up. So there are some spaces where physically you're just not going to be able to do it. It's just not going to work out for you. The other thing too is that we are talking a distance miking application. So where I'm sitting right now, I'm approximately 10 feet away from this microphone. Sounds good. It's got a great sound quality, but as you're going to see in a second, there's quite a bit of difference between what we're talking about with this distance pickup versus a close type of pickup. And in fact, I guess actually it'd be a good point to shift to that right now, is to go over and change over just a little bit to these, and so you can see it, so you can understand what I'm talking about. And again, it's as you're listening to this, I'm sure you're sitting there saying, "Oh, this sounds great," and it does sound great. But if you need isolation or you need a little bit more of that presence and type of pickup, then going with something direct is actually going to be a better choice. So what I'm going to do right now is I'm going to switch off of the ceiling array. And now I'm going to switch to this gooseneck microphone that's in front of me. And so you can hear very clearly a qualitative difference. And you can actually, if you were to close your eyes, you would have that sense and say, yeah, that person's closer. So when you need that kind of isolation, when you need to have that individual speaking, and I guess a great example would be if you've got a presentation going on from a board of directors or a city council, you want the lead council person or the board director to have that clear, clean, close-up audio. And using a gooseneck microphone or something like this might be your better choice. Also, I would say that when you're recording things such as, for example, legal proceedings, court, things like that, you really have to be careful and make sure you get the best possible audio pickup so that for transcriptions, and things like that, you can actually hear who's talking and hear what's being said very clearly. But that kind of is a little bit of a segue there, going from that beamforming ceiling array and now going to this gooseneck microphone. So the gooseneck microphone that I have in front of me right now, this is actually the engineered sound wireless gooseneck microphone. So that brings us into our second of our series here, the engineered sound wireless. So obviously it's a wireless system. It's a pretty advanced system. It's a digital wireless system. As I pointed out before, this is what the receiver looks like. It's a Dante receiver. So each one of these white wireless access point looking things is an 8-channel receiver. So I can achieve 8 channels on just one of these devices. Also, I could actually expand that and have multiple. So I can do, in what we call the standard density mode, I can do 48 channels, or I can even do 96 channels if I go into what's called the high density mode. So if you've got a lot of channel count, a lot of people that need this direct microphone, then this is really a great choice. Now, to be fair, looking at it, it's like, well, how many applications do you run into where you really need 96 microphones? And the answer, in one space, the answer is not many. That doesn't really happen that often. But what does happen often, what happens very often, is where you have a lot of rooms within a building that are using multiple channels. And a great example we actually had, it was in a state house in Albuquerque, New Mexico last year. Within the facility, they had a bunch of rooms that no one room actually needed more than 12 channels. So that wasn't really a big deal, but they had enough rooms in there that the entire facility was over 100 channels. So by going into that high density mode, plus, having rooms that are spaced apart, we were able to achieve that. And that's one of those kind of things that's a great advantage with one of these systems, is that you can change your power levels, you can change your density modes in order to meet the needs for the facility, for the application that you're talking about. Now, like I said, that was a state house, so there's a lot of legal proceedings going on there, and having that clarity was really, really a big important thing. So again, it's about the application and understanding why you need to pick some of these things. So the engineered sound wireless, the gooseneck we have here, that's not the only thing we have as far as the transmitters for this. This is the engineered sound wireless. Like I said, this is the gooseneck one. We also have a boundary microphone, and the boundary microphone has two elements built into it. It has a cardioid and an omnidirectional elements in it. You can choose that in the software how you want to use that. But we did take great care to make sure that they had a very similar character to them. And that similar character, I'll switch through them right now. So this is the gooseneck microphone. And now I've muted that and I've unmuted the boundary microphone. So you can hear that they have a very similar character, very similar sound quality. But here's one of the things that is going to help you understand why you might want to choose one over the other. So first, I'm going to go back to the gooseneck. I'm back on the gooseneck mount now. Now Dan's going to trigger the gooseneck over there. He's got a gooseneck in front of him. They're using the same microphone elements, and you can say something now.
Something now.
You know, I'll talk on and on and on if you let me. So the thing is as we sit here and talk at the same time, and if I talk about rejection or I talk about isolation, that doesn't really mean much because you can hear me, you can hear Dan very clearly.
Right.
You know, that's what but here's the reality. I'm going to mute my microphone that's right in front of me. So now I'm talking and I'm only getting picked up off to the side on Dan's mic, where when Dan talks, he's still present and clear.
Yeah, because mouth is pointed right at the shotgun style element, this microline element.
Yeah, and you can hear that now that mine's back on, there's quite a bit of isolation there. So if you have people that are sitting close together like Dan and I, but you need some degree of isolation between them, then picking the gooseneck microphone is absolutely the right way to go. Now, the catch here, of course, is if you've got a lot of people and you need a whole lot of wireless microphones, that can get a little bit more difficult, saying, you know, I need 20 or 30 microphones, wireless microphones. That can get a little more expensive. But you could take something like this cardioid boundary microphone and put it between a couple people. And now I got it set up. I'll try to make sure it's right in the middle of it. But now I've got it set. This thing's got the 120-degree wide pattern, and I'm sitting off to the side of it, and it's picking me up fine.
It's picking me up fine too. That 120 degrees, yeah, it's swinging 60 to the left, 60 to the right, 60 up, because since this is a boundary microphone, the other part of that 120 degree, the 60 down, is being blocked or being covered by the boundary.
And it's rejecting what's going on behind it. So here I can say, you know what, I can do a 2-to-1 type of situation here where I can use just one of these microphones to pick up 2 individuals. So I can, you know, try to conserve, you know, audio channels. I can try to manage price and things like that. So these are some other considerations. Now, you're listening to this and you can say, okay, well, that sounds great. I like that. What's the catch? The catch is you can't isolate. So, and Dan's voice is actually a little louder than mine, and there's no way I could go into a digital signal processor and try to make compensations for that because they're being picked up at the same point.
Yeah.
I figured you were going to talk over me at that point.
Yeah, I
since
mean,
you're running louder than
that's
I am,
I do tend to project.
So and so that's something you have to consider too. Again, it's about the application, what's happening there. If you've got a louder person sitting next to a quieter person, then maybe this isn't the right choice. Maybe this one isn't going to do it for you. So these are the different options. Switch back to my gooseneck now. These are the different options you have between these tabletop type ones. Now, one of the other things I do see a lot of people looking at is they look at their handheld type of microphones. And you know, handheld microphones are great. And in fact, if you're talking about a situation where you want to get the most isolation and the best quality out of it, your handheld's probably going to be your #1 choice. However, the person using it has to know how to use a handheld microphone. And if they don't use it correctly, you're going to have a problem. So as I switch this microphone on and I'm talking into this, which this is a dynamic cardioid element, and it is fully intended to be used at this kind of proximity, very close to my mouth. So, you know, this is the way it's intended to be used. And if you've got somebody who's giving a presentation and knows how to use it like this, then that's great. Actually, when I tend to stand up and give presentations, I actually prefer a handheld. The problem is if you give this to a presenter and they decide to hold it like an ice cream cone, which I've seen a million times, you end up with something like this. Now, you've just now lost all of the body of the audio. You've lost all that body from it. You've lost significant volume. So now there's much less volume. And, could I compensate for that by turning up the volume? You could, but you're still, again, this mic's designed for close-up use. The biggest problem you run into is what happens if you've got a presenter today who doesn't know how to use it and they put it down here and you turn the volume up and then they hand that microphone to somebody who does know how to use it. You end up with these large variances, and you're either going to end up with one of two things. You're going to end up with severe distortion, as that signal overloads, or you're going to have to gauge a considerable amount of processing on the back end to level that out in a digital signal processor, which ultimately is not going to do you any favors from a sound quality perspective. So, understanding where a handheld is good and where it's not good. Now, I also see a lot of times I'll see people put a handheld on a small tabletop mic stand where they'll put it out here like this. You should be using a gooseneck for that situation. This, again, you run into that same problem. This microphone was meant to be used up close. So, that's my little thing. I did want to point that out on handhelds and let you at least hear the difference on that one. So I'm going to switch that one off for a second.
Comment here is
from
Rory. I think I got that right. Oh yeah, makes sense to turn my mic on, wouldn't it? We got a comment in that if you're not within the frame, there is no picture. Then you draw a box in front of the user's mouth. Yeah, I mean it's very important. Microphone etiquette, especially when it comes to handheld microphones or even directional microphones, is extremely important. But that's where we have a lot of solutions that could cover these different application types, where if somebody's going to be moving around a lot, maybe the handheld is not the right choice for them. Maybe a ceiling array is the right choice for them.
And actually, I was just going to mention that we talked about earlier is the application is going to drive what your choice is. And if you know that you're not going to be able to educate the user, and it's just, and I hear this from university people all the time, where the university people are like, what, this professor or so-and-so is just, they never listen, they never do this. Everybody's got a story like that. Well, then maybe the application there is, look, the only way we're going to solve this problem for your application is to spend that extra money, to put the extra effort, and use a ceiling array that can track things automatically. So there's that. So there's that about that. Last transmitter type I wanted to talk about, which is also an option too when you're talking about that individual that wants to move around, is using a body pack microphone. Now, this is the body pack microphone for our engineered sound wireless. And what's cool about this is you can actually use a couple of different things. You can use the built-in omnidirectional microphone, or you can put a lapel mic. Now, here's my thing about lapel mics. There's a time and there's a place for lapel mics, but there's a lot of things, again, about the application that you must consider. And a lot of that has to do with placement of this microphone. Now, if you are able to, prepare the person before they go on stage for a presentation or something, where you can literally, almost like a broadcast application, where you can go up and make sure that microphone is fitted and positioned in the correct place, then yeah, lapel microphones are great. They tend to be, I'll clip this one on. They tend to not look that terrible. They're you can put them right here, do something like that. The difficulty comes in two places. One of them is not everybody has the same clothing style. With myself here, I've got a nice button-up shirt, so there's an easy place to put this in the center, but that's not always the case, where you may have to place it in different size to the left or right. And then if you have the presenter, the individual positioning themselves, then you may get inconsistency where they don't clip it in the right place, or if it's directional, they point it the wrong direction. So you can set yourself up for difficulty, again, depending on the knowledge level, the skill level of the individual that's either wearing the microphone or putting it onto the person. So, a lapel mic, you can attach that to something like, this wireless transmitter, and you can use that so that they can move around freely. Now, one of the things that I think is rather exceptional about this belt pack, and obviously I'm biased, it's my personal opinion, but I'll let you guys listen to it and you can decide for yourself, is that the omnidirectional microphone that's built into this is actually really a good sounding element. And I'll just hang this thing around my neck here. You can just hang it around your neck like this, and then I'll switch over. And so now I'm on, well, we can mute Dan there. So now the only mic that's active is this body pack that's around my neck right now. This is the omnidirectional that's built into this. And it's got a really natural sound. It can withstand, me turning my head to one side or another and things like that. So it's actually got that good natural pickup. And actually an omnidirectional is going to give you, out of all the different ones, it's going to give you the most natural sound out of all of them. What's the downside with this then? I mean, this is pretty cool. It's pretty lightweight. It's comfortable to wear around the neck. What's the downside? Well, it is an omnidirectional element to say that it picks up audio from all directions. In this application where we're talking right now, that's absolutely no problem. Just like when you watching the evening news or watching a show where they actually have these lapel mics on, those are usually omnidirectionals because they're not feeding into a local sound system. So they're not doing local voice lift or local sound reinforcement. And yeah, that would be the right choice if you aren't doing that, if we're doing a presentation like I am now. If you are in a situation, for example, a large classroom where you have to do, the instructor needs voice lift so that audio can then go through a system and then into speakers in the back of the room. An omnidirectional microphone, since its nature is to pick up from all directions, is going to be much more prone for pulling some of those reflections in and potentially turning that into feedback. So they're your trade-offs. This sounds great, and I'd love it if we could take, every city council member or every school board member or whatever, and just toss one of these around their neck, and then you can get a great constant sound. But there are other considerations that you have to look at. Also, I do want to point out another cool thing about this transmitter. Another reason that I like it is multi-purpose capability. That because it's an omnidirectional, I could actually put this on the table between Dan and myself here. And we could actually use this as a dual purpose mic.
Right.
So I had it as my lapel or body pack that I wore, but now it's a tabletop omnidirectional.
Yep. Now it's a boundary microphone.
Because it's sitting, on a boundary.
Right.
So yeah, so that gives you a lot of flexibility there. So understanding what these different transmitter types are, the different kind of flexibilities and the form factors and all that is really critical. And again, as I've said it time and time again, and I'll keep saying it, it's about the application, right? So it's about who's going to be using it, how are they going to be using it? Do we have a lot of different players on the scene, as it were? In other words, are you going to have somebody in today that really knows how to use that handheld, and then this afternoon somebody that doesn't? These are all the things you have to ask that are going to guide your decision on what you're going to choose out of all these type of microphones. Now, we've talked about the ceiling array. We've talked about engineered sound wireless. Now, engineered sound wireless, again, it's a great sound mic, and I'm going to switch back to my gooseneck before I forget it and then I start doing something else. But so engineered sound wireless, obviously it's a great sounding microphone. It's only a Dante system. It's a large scale capacity system, and this does drive the price a little bit higher. Dante itself comes at a price. Being able to do this larger scale comes at a price. Some of the options, like the sound quality you just heard in that built-in microphone in the body pack, those things all come at a price. But we also have some other options there, and that option I'll point to here is actually System 20. And System 20, actually the transmitters that Dan has been using over here, the gooseneck mics, is actually a System 20 transmitter versus the ES Wireless that I'm talking on right now. And I'll tell you what, I'm going to do this. I'm going to switch, steal some of Dan's thunder here. So I'm going to switch back and forth. So right now I'm talking through the engineered sound wireless mic. Now I'm going to switch. Now I'm talking through System 20. So System 20 Pro, engineered sound wireless. And you can hear as I switch back and forth from one to the other, that's real close in sound. So we really did look at it and say, hey, what can we do to kind of scale the system down but still maintain that quality in audio? There, I did it again. I had the wrong one. How can we scale this down but still maintain that quality of audio that we're known for? And that's where we came up with System 20. And System 20 is actually the next generation, the next iteration of System 10 Pro. System 10 Pro was around for more than a decade before it was replaced by System 20 Pro late last year. System 20 Pro operates in the 2.4 gigahertz spectrum, which some people do worry about that, but that System 10 had managed to function very well, and I'm sure there's many people on this call who have actually used System 10 Pro and are happy with it. And I'll say this about System 20, it's way more advanced than System 10. It can actually do twice the number of channels in half the bandwidth, so it's even able to deal with those busy environments even better now. Now, we did do a few things that kind of shaved us cost on those. So, you're not going to have a digital audio output. You've got this half rack device piece here, which is going to have 4 analog outputs on it, but we don't have Dante on it because Dante comes at a cost. If you don't need Dante, you could still get that same sound quality from that we got from Engineered Sound, but in a lower price point. If you don't need that built-in mic, we still have System 20 still has a belt pack that can use any of our lapel or headsets. We've got the handheld microphone. Battery life is a little shorter on System 20 Pro, but even with that, we're talking anywhere from 12 hours to 18 hours, depending on which transmitter in System 20 Pro, as opposed to Engineered Sound Wireless, which goes anywhere from 17 hours to 35 hours. So you have to start looking at the application. Do you need that long battery life? Yes, I do. Well, then you're going to have to go with Engineered Sound. I only have a couple of channels and they're going directly analog in. I don't need Dante. Then you should be looking at System 20 Pro. And so we've got these different options to allow you not only to hit the applications themselves, but to pick the product that makes sense for the application. Spending a lot of extra money on features you don't make sense. At the reverse side of that is, having to buy a bunch of other peripheral piece of equipment to get the features you need when you can buy them built in. That's also something else to look at. So these are some very important points. Now, I also want to point out, I'm running a little ahead of schedule here, but that's okay. I also want to point out that from an integration standpoint, each one of these 3 devices has a lot of interoperability power to it. Now, and actually with System 20 Pro, System 10 didn't have this. And what I mean by that interoperability is the ability to talk to other systems or other devices within a system. For example, QSYS plugins, available for all this stuff. I think that the QSYS plugin for System 20, I think, is just now coming out, but still, we have the ability to do that remote control and remote monitoring using things like QSYS or Biamp or Crestron or Extron or any of these type of things. We use, TCP/IP kind of command controls. It's an open API, so we're ready and very happy to work with any of the other manufacturers out there to make sure that our equipment talks together well. And, I can go on and talk about these capabilities, but let's look at it for a real world application for a second. What does that mean and why can that be useful to me? Well, one of the things is, as we noticed here, I'll give, for example, we're going to switch over to boundary microphones, and I'm going to have one boundary microphone in front of me and Dan has one in front of him. They're both on right now. Now, if I decided, let's say I'm sitting at a board of directors and I have somebody over here on my right that I need to talk to, I can say, oh, I'm going to mute my mic, and then I say, man, this is really boring. I wish we weren't doing this anymore. Well, problem there is that Dan's mic is still open,
right.
And that's that classic mic, open mic, hot mic situation you get some politicians have gotten in trouble for. Well, having the ability to work with a remote control system means that when I press the mute button on this microphone, it then sends that information out on the network to be captured by another device. And a classic use for that would be, you know, when I hit this, it goes to QSYS. QSYS sees the mic is muting. And then it turns around and mutes all the other mics. So it can be an all mute, and it turns everybody's red. And this can absolutely prevent that kind of thing. And it can make it so that, all right, well, I'm the CEO here, so I'm going to mute this, and I'm going to mute it for everybody. And there's really a lot of different combinations. And actually, you know, I think a lot of the imagination of integrators out there, I've seen some pretty cool things that people are able to do with these controls to be able to talk back and forth between DSPs to manage things like this. So having that remote control, the ability to monitor things and see what's going on using our software, such as our digital microphone manager or our wireless manager software, or using the API with other stuff, you're able to remotely monitor and see things like RF levels and audio levels and mute status and all that kind of stuff, charging battery status and things like that. So there's a lot of use to using some of these external systems. Sorry, I need to drink water there. Now, also what you're talking about with that, when you start dealing with these integrations, you're also talking about the ability, scalability, automation, and actually one of the cool things is you can add features, you can add functionality to an application with really not a lot of extra costs. I mean, the ability to remote control the stuff is already in there. You know, if you're using ES Wireless, or even if you're using System 20, you're going to probably have to have some other DSP out there that you're going to need to use to do echo canceling and mixing and all that. So to be able to incorporate some cool features is actually, you know, more value you can bring to a job, you know, more value you can bring to your design and your installation. So that's pretty, I'm not actually that far behind things. I'm about 7-8 minutes ahead of schedule. Dan, do you have any points that you want to add in there to clarify?
No, I mean, sure. Yeah, certainly. Certainly I do. One of the things that you touched on as it relates to, you know, third-party controls was that you can have it so that a button can be pressed and then it can mute everybody else's microphone. So although we're not featuring our discussion systems here today, you can make it so that it functions similarly to that discussion system where a button press can initiate an action. So that's some of the things that you can do with engineered sound and with System 20 Pro.
So that's an important point, and the way that you phrase that is that you can use the button to initiate an action. Now, we always associate these buttons on these microphones with mute and unmute. But what we're talking about in a control situation is you're merely sending a signal out to the DSP that says, this button has been pressed. And it's up to how you program the DSP as to what that means. You know, that can be a mute all. It can be answer call, you know, incoming call. I'm going to hit that. It answers the call, sends a signal to the system, and actually picks up that Teams call or that Zoom call. And really, it comes down to your imagination. So yeah, like initiating a function actually is a really good way to put that.
Yeah, thank you.
Anything else? Any questions come up?
Yeah, we had a few. So let's just go to the last one that came in. What AT component replaced the now obsolete R1500? Is there an existing AT receiver that will work with the AT System 10 Digital 2.4 gigahertz transmitter?
So the System 10, all right, so just so you know, a little background, you've got System 10 and System 10 Pro. Both of those systems, they use the same transmitters, our System 10 transmitters to T1001, 1002, same transmitters there. System 10 Pro was discontinued, and what was discontinued there was that Rack Mount Pro receiver and also the boundary and gooseneck transmitters. Now, the handheld and lapel transmitters and that tabletop System 10 receiver still exist. Those are still current products. The 1500, what was the 1500?
I think, so the 1500, you know, we had different System 10 receiver form factors. There was the 1500, which I believe was the stomp box.
Yes.
And I think there was the 1700, if my memory serves
1700 was
me
the
correctly.
portable. So the 1100 was the tabletop. one, which still
That's it.
exists,
Yep.
and it still exists with the handheld and belt pack transmitter. The 1500 was the stomp box, which was a guitar. It was meant for guitar, so it was a receiver that sat on the floor that had a button on it that you could use to mute and things like that. And that was discontinued, actually a couple years ago, and there are none of those that are left. The 1700 was a portable receiver. It was a little one-channel portable receiver that you could put on a camera mount for like ENG, electronic news gathering, things like that, which has also been discontinued. So the technology that we're seeing in System 20 Pro is the future of it. If you have some of the 1100 series that you're currently using, the tabletop System 10, the handheld and belt pack transmitters, those are still going, and those are still being produced.
So a question that I'll answer here very quickly is, can you create AES-67 flows in, or is ESW AES-67 compliant? And the answer is yes, but it would be through Dante Controller. In Dante Controller, if you click on your device and go to, I believe that there's a tab at that point for AES-67.
Let me see if I can call this up here.
You could create that AES-67 multicast flow there.
So I'll bring up on the screen here the Dante controller. So if we go over to the ESW, where's that ESW?
That would be
This
at
is
the
where I
top.
read things sideways. So if I open this up, I double click this, and this is the interface for the engineered sound wireless receiver. So when we go over here to the AES-67 configuration tab, that's where you're going to enable that. You're going to enable all that and for AES-67. And actually for all of our Dante enabled devices, no matter which one it is, they are all AES-67 compatible, and they're all something that you would change, that you would set up through Dante Controller.
Another question that came in is understanding how diversity works, RF diversity works in System 20 Pro, and as that relates to 4 microphones and 4 antennas.
Okay, so kind of explain how that works.
Explain how diversity works with System 20 Pro.
It's easy to look at System 20 Pro receiver, and I'll try to hold this up so it's a little clearer. I'll hold it in front of my blue shirt. You can see the receiver. This is a half rack. It's capable of doing 2 channels in the standard density mode or 4 channels in the high density mode. And it's easy to look at these 4 antennas and say, oh, maybe these 4 antennas are for each of those 4 channels. But that's actually not what they are. So that's actually 2 pairs of antennas. So each pair of these antennas is a diversity pair that goes into 2 different transmit receive paths. So that's actually what we have going on here. To do a real quick how does this work kind of thing. So System 20, the way it operates is when it lights off, it listens to the environment, right? It decides what area is clear. That's phase 1. Phase 2, it uplinks from the receiver to the transmitter operating frequencies. I say frequency, it's giving a primary and a secondary, a primary and a backup frequency that it's giving to the transmitter. Then in phase 3, the transmitter will transmit back its data, audio data, control data, mute data, and all that kind of stuff on 2 different frequencies that are spaced apart very, very slightly in time by a single frame, actually measured in microseconds. Actually, it'd be in microseconds, so very, very little. And so what you have is technically you actually have a few different levels of diversity here. One of them you have time diversity because you have those 2 different times that those frequencies are. So if you get interference on the first one, the second one will have your data. The second one is, your actual frequency, because in those two frequencies, there are 2 different frequencies spaced out, so there's going to be a less chance of an interference. And then last comes down to this antenna placement. But you need all 4 of these antennas, whether you're operating on 1 channel or 4 channels, right? Because what we have is we have the antenna diversity, which is feeding there to pick which antenna has the strongest signal, and then we've got a primary and backup one too. So that's kind of how that relates, I know that's kind of a real quick down and dirty, and I hope that answered your question on that one. But that's a real quick one on how System 20 works.
Good question. Do we have any other questions? And anything else that we can answer for you live?
Yeah, because I can't answer after this is done. Well, I can answer.
Guess we
I just can't-
could.
yeah, we could probably edit it back in here if we really wanted to, but I don't know how that's going to work. Well, I can't read that.
Yeah.
That's what he's got. So Rory puts a white piece of paper up with an ink mark on it. It's like, I can't read that.
It says Q&A. Question and answer time. Let's look here.
We can open up the floor and
Okay.
see if there's any additional questions, anything else.
Oh,
anybody
there's, okay. Very good. Best practices for using thank you, Rory. Appreciate that. Best practices for using the ATND1061 with assorted wireless microphones.
That's a really good question.
Yeah.
And this is one of those things that almost deserves its own topic because there are a couple of things that you have to concern yourself with. Number one is the latency problem. Because if I've got a handheld microphone here, I'm a presenter and I've got a handheld microphone, that time between my voice arriving at this element versus the time from my voice reaching the other element, you're going to have a significant latency difference. I mean, you're talking about, in this particular case where I'm sitting here, that could be as much as 10 milliseconds or more, depending on how far away you are. So, that can create some pretty serious problems there. So you have to be aware of that. One of the ways that you could do that is you could actually delay the wireless microphone transmitter to try to match up with it. The trick there being is you're going to have to find a happy medium, because as you get closer and further away from that ceiling array, that latency number changes. So, you can't really change the delay on the wireless transmitter in real time like that. So that can become tricky. So that's one of the parts of the problem. The other part of that problem is there's a significant amount of delay in the processing of a ceiling array anyway, so which is going to make that problem appear even worse. So, what are some of the best practices? If I absolutely have decided that this presentation, this instructor, professor up at the front is going to be using a lapel, I'm going to be doing that because I want to do a strong voice lift to the back, then what you need to do is you need to make sure that ceiling array, there are no beams covering that area. So you want to have it kind of a one or the other. And the one way to do that is have the body pack microphone on, but have the beam forming array not covering that area where the instructor is. So that's another good practice on it.
Yeah, and I'd say even as it relates to our product specifically, I think that gives us a nice advantage because we can draw zones in different areas. We can pull a zone away from where somebody's using a wireless microphone. So that I would absolutely say that's a nice advantage for us. Another thing too is if you have a microphone at a lectern, then your delay time is for the most part fixed. You're not really moving around a lot. You're staying in more of a fixed position. Where it could get a lot more complicated is if you are using a handheld microphone and you're walking across a certain area, because as you move further away from a ceiling array microphone, your delay time is going to increase. It's now you go from more of a fixed delay time to a more dynamic delay time where it's gonna the delay time is gonna increase, it's gonna decrease, and it's really difficult to plan for that. So another thing you could potentially do is add a gated auto mixer where a microphone, the wireless microphone would have priority, and where whenever this is on, it takes priority over every other microphone and will gate those microphones off. So those are some of the other things that you should consider and can do in order to mitigate some of that double audio that you might hear from having a wireless microphone and a ceiling array at the same time.
Good, excellent question.
Is it possible, this is from Dennis, is it possible to pair ESW transmitters to an ESW receiver without the use of the CHG5 charging station?
Unfortunately, no. That's kind of that's the bridge in the system. That's what's used to program, and there's no way to program one of these tabletop microphones or any of these ES wireless microphones without using its associated charger. Now, that being said, once you program it, you don't have to have that charger. You could then go to, which I didn't mention this, but these transmitters have USB-C connectors on there, and that USB-C connectors can charge it. So after I initially program this on a CHG5 charger, I could then just use the USB-C for the rest of its life. It would never have to see that charger again. But for the initial programming, you do have to have that CHG5 charger.
Let's take it back to the 1061. And one of the questions is, so if the wireless is in the 1061 exclusion zone, can the 1061 still trigger a camera into position?
Well, there's an interesting question. No, actually, an exclusion zone, it takes the highest priority of all zone types in the 1061. So what the exclusion zone will do is it will suppress location data for that area. Now, what you could do, though, is you can not draw a zone in an area at all. So you've got an exclusion zone which says, it's excluding any voice from there from activating a beam. Not having a zone there at all is the same thing, but that location data won't be suppressed. So you could do it that way, not with an exclusion zone, but actually with the lack of a zone, period.
Let's see here, going back to the chat. On the subject of diversity, in HD mode, there would be 4 antennas and 4 microphones. If we have 2 antennas doing diversity in HD mode, we would have 4 antennas doing the transmission with 4 microphones, thus 1 antenna for 1 microphone.
So it doesn't really work that way. So
yeah, it works a little differently.
Here's how this is working. This receiver here is using 1 primary and 1 secondary frequency, no matter if you're using 1 channel, 2 channels, 3 channels, or 4 channels. What's happening is you're time sharing those 2 primary and secondary frequencies. And so what you're looking at with these 4 antennas is you're looking at 2 pair of diversity antennas. And I know I'm playing with these antennas and you can't even see what I'm doing. So you've got 2 pair of diversity antennas which are correlating to those primary and secondary frequencies. And they are in use no matter how many microphones you're using in this. Whether it's, like I said, 1, 2, 3, or 4 microphones in use, they are using the exact same primary and secondary frequencies. It's just the data is different depending on the timing. So it's like I said, it's a TDMA or a timeshare kind of thing. Hope that clarifies it.
Okay. What battery packs do I put in System 20 handheld body packs? Oh, and body pack, let me see, and body packs to work with the CHG3 charging station. So I think that's what type of batteries should we use or what type of rechargeable batteries do we recommend? I'll answer that one. So any nickel metal hydride battery that has a milliamp hour rating of 1900 hours or greater. A lot of the ones that without making a specific recommendation, there are plenty out there that do 2000, 20, 22, 21, 22. The highest I think I've seen is 2850 or 2900 for a nickel metal hydride. Another one would be a rechargeable lithium ion battery. That's what's going to give you the highest amount of battery life. The performance between these batteries in terms of your audio, that's going to remain the same. It more so has to do with what type of battery life you are going to get out of the system. I think if my memory serves me correctly, a standard alkaline battery gives you your baseline performance. And I think that's based on a 1900 milliamp hour from a nickel metal hydride standpoint. So if you go higher into the nickel metal hydride world and go to, I don't know, see 2400, your battery life is actually going to be increased.
However, your charge time will also be increased.
That's-
Just keep that
that's
in mind.
it.
That's not significantly. I mean, it'll take a couple more hours to charge it to full, but still, you know, it's just the higher that is, the longer the battery life will take, the longer it'll take to charge. But great question. So there are a lot of options, and I know Dan didn't want to say. I like personally, I like using like the Panasonic Eneloops. They work real well. They're not the cheapest ones you're going to find, but they're reliable.
All right, I'm going to put this in the chat here in a little bit, but it looks like we've gotten to 3 o'clock.
Yeah.
If you have any questions, be it, hey, I have this application use, I have this project and I'm looking for a solution, or, really anything else. If you have any questions about Audio-Technica products, feel free to reach out to our team. It's aeteam@atus.com. That's A like applications, E like engineers, and team at ATUS like Audio-Technica United States.com.
We're here to help. We're here to help answer questions on applications, to help figure out the problems, and that's what we enjoy doing. So, please reach out to us.
All right. Thank you, everybody.
All right. Thanks.